Hello, in this video we're going to talk about uniform motion, and we're going to use a special formula that works for all the uniform motion problems. D equals RT. So D equals RT stands for distance equals rate times time, and this is the basis of all of the uniform motion problems that we're going to work on. So uniform motion means that something's moving at the same speed. That means there's no acceleration, no deceleration. It's just we're assuming that this speed is constant, which is virtually impossible, but we're just going to assume it for purposes of this problem. And this is going to be a part one of a three-part video series. So part one is going to be the easiest because we're going to talk about equal distances. So looking at this problem, let's read it. Looking at this problem, we have Richie hopped onto his bicycle and pedaled to the park at 15 miles per hour. This is a rate. Then he whizzed back at 20 miles per hour. This is another rate. And the total trip took 1 3/4 hours. This is a time. And the question is, how far was it to the park? So what we're looking for is distance. And we're going to want our answer to be distance in miles because we're talking about miles in this problem. And so it helps to draw a diagram. So what's happening is this person goes to the park and goes home. So there's two different distances, and each distance has its own rate. And actually the distances are not different. So just to illustrate that, I'll draw a diagram. This first arrow I'll call DP, which means the distance to the park, and the second arrow will be DH, which means the distance home. And I drew these arrows about the same size because the distance to the park should be the same as the distance home because the park and the home are not moving in space. And so the main equation I can use is dP equals dH. The distance to the park is the same as the distance home. Now, in all of these uniform motion problems, we're going to be replacing D with RT. So I'm going to replace dP with RP, which means rate to the park, times TP, which means the time to the park. And I'm going to be replacing DH with the rate home times the time home. So this is exactly the same as this equation, it's just another form of it, because we know that D is always RT. Now, under my diagram, I'm going to write down what I do know. So I can start to substitute the values that I know. RP means rate to the park, and we know that the rate to the park was 15 miles per hour. So I'll say 15 mph. The time to the park, I don't know that. I know the rate home, so I'm going to say RH equals 20 miles per hour. And then the time to the park and the time home, I don't know what they are, but I do know that they have a relationship, that they have to add up to 1 3/4. So what I can do is I can say TP plus TH, the time to the park plus the time home. The total trip is 1 3/4. 1 3/4. Which usually you can convert it to a decimal or you can convert it to an improper fraction, which is what I prefer. So to convert it to an improper fraction, I go 1 times 4 is 4, and I add 3, which is 7. So I have 7/4 instead of the mixed fraction. And last step before I can start plugging things in is I want to just get one of these alone, so I can move the TH to the other side of the equation and say TP equals 7/4 minus TH. And I'll put that in parentheses. So I can just substitute that in for TP. All right. So let's start subbing things in. RP is 15, so I replace that with 15. TP is this whole expression, 7/4. That looks like a 9, but it should be a 4. So let me fix that. 7/4 minus TH. RH is 20, and I'll leave TH just as TH. So the reason I did that is because I want everything in terms of the same variable. So t sub h is the thing that I can solve for. So let's go ahead and do that. So I can go ahead and use the distributive property, doing 15 times 7, which is 105. I have 105 fourths. And then I do 15 times negative th, which is negative 15 th equals 20 th. So the rest of it is just solving equations, which we all know how to do. And then I add 15 to both sides, and I get 105 over 4 is equal to 35 th. To get the th by itself, I need to divide both sides by 35. And dividing by 35 is the same thing as multiplying by 1/35. So I can go ahead and do that. I can cross cancel here because 105 is actually divisible by 35, and it happens to be 3. So I can cancel that. That's a 1 and that's a 3. So I get 3/4. 3/4 is my time home. So 3/4 of an hour, which is actually 45 minutes, is my time home. That's not the question. That's not what the question was asking for. The question's asking for distance. How far was it to the park? Well, I know that the distance home is the same as the distance to the park. And since I have th, I can use dh. I can say distance home is rate home times time home. And I already know that the rate home is 20 miles per hour. And I know that the time home is 3/4, which I just calculated, 3/4. And I can cross cancel there, get 5 times 3, which is 15. 15 miles. So 15 miles is the distance to the park and the distance home. We're going to do a couple more examples of these types of problems just so that you can practice. So what I'm going to do is I'm going to encourage you to pause the video while you try the next 2 examples on your own and then check your answer with me. So let's go ahead and get started on those. Example 2. Emily put on her jogging shoes and trotted to the park at 6 miles per hour. Then she raced back at 10 miles per hour. If the total trip was 6 2/5 hours, how far was it to the park? So very similar to the last problem. Go ahead and give it a shot. Try to set up the diagram and everything on your own, and then press play when you're ready to check your answer. Checking the answer for example 2, the diagram is pretty much the same as example 1. The distances are equal, so the main equation is dp equals d sub h. And then, just like before, I wrote down all the things that I knew, the rates and the times that I knew, and then just plugged them in and solved for th. Now once I solved for th, I just plugged it into dh equals rh, so the distance home equals rate home times time home. And if you want to write the units, you can see the units cancel. Miles doesn't cancel. Hours cancels, and so you end up with 24 miles. All right, let's do one more example. All right, example 3, it's a very similar question, so go ahead and try to draw the diagram and solve the equation on your own. Okay, so checking the answer for example 3, it's the same type of diagram. The distances are equal, so it's the same type of equation as well. And when you plug in all of your unknowns, or all of your knowns, you can find the unknown time, which is the time home. That gives me 3 hours, and I plug it into the dh equals rh times th, and I get 3 times 3, which gives me 9 miles. All right, so this concludes the first part of this series. Parts 2 and 3 are going to do some more uniform motion, but a little more complicated.